Hi everyone, my name is Mohit Khan, and I'm the offering manager for energy upgrades at Armstrong Fluid Technology. Today, we will be speaking about some building systems, more specifically, key systems associated with water, their effect on the built environment, and the solutions to many of the problems associated with them. Spoiler alert, the solutions are based on digitalization and the active management of these systems through the use of analytics. Now, as the presentation goes on, please feel free to plug in any questions you may have in the comments below, and I will answer them as this presentation goes on. So let's get started by framing the opportunity. Today, 55% of the world's population lives in urban areas, and by 2050, this number is to rise to 70% of the world's population. Now, most buildings that will exist in 2050 in Canada have already been built, which means that to achieve a net zero carbon future by 2050, our industry must optimize the systems of these buildings, be it by operational optimization or through retrofits. Now, as mentioned earlier, we will be focusing on water-based systems for the purposes of this presentation. Water enables the built environment. Necessities like drinking and washing are enabled through plumbing systems, which can be optimized largely through hydraulic improvements. And on the other hand, heating and cooling are enabled through HVAC systems, which often use water as a medium to transfer thermal energy. These systems are far more complex and are optimized through system-based monitoring and flow control, leading to efficient heat transfer through the building's load profile. The movement of water is a lifeline for any building, and managing it effectively is the key to ensuring a comfortable and sustainable future. So first, let's start by looking at plumbing. How do we get water to everyone in the building? The city provides water at a certain pressure, often at the ground or basement level, and it is transported through the building via piping. Water pressure is boosted by pumps, known as booster pumps, to ensure the entire building has access to water at a comfortable pressure. Since this equipment is often designed for peak usage and has a number of safety factors tossed in, it is often oversized for at least 90% of its operating life. This makes it operate inefficiently for the most, if not all, of its operating life. This, combined with factors such as equipment age and energy drift, all but ensure a significant wastage of energy along with exorbitant maintenance costs. So let's look at building load next. Water usage can vary considerably throughout the day in buildings. For example, a residential building could experience peak flow usage in the morning as many people get ready for work at the same time. At night, this same building could use almost no water when most people are sleeping. Even though the flow rate used in the building could vary greatly, each fixture still requires constant pressure for proper operation. So, how is this load handled? Traditional booster pump systems maintain a constant pressure supply to the building via a pressure reducing valve or PRV. This configuration is called constant speed because the booster pumps run at full capacity to increase the water pressure, and then the pressure is immediately reduced by the PRV. So why is this strategy a bad idea? The water pressure to the building stays constant, but the utility bills are much higher than necessary. Constant speed systems also consume excess water through flow and leakage associated with higher operating pressures. Additionally, maintenance for such equipment is expensive due to high runtimes leading to maximum wear and tear, as well as really high PRV maintenance costs. So what's the solution? Presenting the design envelope booster. Each design envelope booster uses vertical multi-stage pumps in a 2 to 5 pump arrangement, combined with variable speed controls and efficiency-based pump staging logic to create broad envelopes of efficient hydraulic performance. The design envelope approach to selection reduces design risk due to set envelope and maximizes high-efficiency operation. The selected booster system can also accommodate changes during the design and construction phases and over the life of the building, wherein pumps can be added and removed as necessary. Now next, let's look at heating and cooling. Studies have shown that heating and cooling costs currently comprise 56% of building energy use, and this percentage is increasing as energy efficiency measures in other areas continue to penetrate. One example is the implementation of LED lighting, which can reduce the lighting consumption percentage from 15% to 5% or less, thereby increasing all other components proportionally. Additionally, such a change could also lead to the reduction in thermal load, which also changes the way your heating and cooling systems operate. Now, while the blue areas are well understood and advances in efficiency continue to make significant progress, little is happening to address the heating and cooling contributions of the energy problems. This is where we must consider various approaches and solutions that can drive significant reductions. The power of today's transparent data and analytics is in avoiding the energy drift in projects, which often results in savings degrading. Studies have shown that this can amount to as much as 30% in as little as 2 to 3 years' time. However, through the use of transparent data and active performance management, savings can be sustained through the long term, ensuring realization of your initial value proposition and return on investment of your projects. But why is it so hard to achieve significant energy reductions in existing buildings' heating and cooling systems? Firstly, a typical HVAC system is designed and is fundamentally built on islands of functionality, with attempts to provide integration through control of the islands by varying speed to achieve set points. Often, these islands only inform their neighboring islands, if at all. Now, there are many reasons for this. Some of the common ones include manual interventions to address tenant comfort issues, changing functionality of buildings, like I mentioned earlier with the lighting example, load variations, and so on. These issues end up trapping approximately 30 to 40% of energy in energy wastage. We define this as the energy white space in the building mechanical plants. But what if we approach those islands and the energy waste white space between them by first understanding flow? In the same way that your heart informs you of the needs of your body, your building's pumps and the flow needs of the major energy consumers of your building, such as your boilers, chillers, and cooling towers, can provide enormous understanding of the heating and cooling needs of your buildings. So let's look at this further. Through experience in real-world implementation, we've learned that the pumps of a building act just like the heart in our body, sensing a building's energy and comfort demands through increased requirements for heating and cooling. The key to benefiting from this is true integration between systems. New integrated sensorless pumping technology can measure flow rate just by knowing its horsepower and speed. The pumps provide an enormous amount of information directly back to the building operators and building systems relating to system performance. And this data is available directly from the pumps through serial communications to the BAS, through the Wi-Fi connections to a smartphone, tablet, or PC, and of course on the pump display screen. By starting with an upgrade to intelligent pumps on the distribution side, we can get a much better understanding of the load of the building characteristics of the system and its components. It makes system operations transparent to the building automation system, the maintenance management system, and the energy management systems. And like a healthy heart, it leads and it adds to the efficiency of other equipment of the system by ensuring the right flow rate, and then to cooling towers and chillers. But most importantly, it can be a cash flow positive investment from day one. This leads to up to 10% energy savings on the plant. Now we add intelligent pumps to the condenser loop and get better insight into the tower profile. These insights help us make informed decisions on the next cash flow positive steps to upgrade, which could include control and optimization of the condenser loop, converting towers to variable flow, and headering the towers. These integration and optimization steps provide further flow insights to the plant and building requirements and can deliver up to 30% in energy savings. Only after these steps are complete do we move on to upgrading and right-sizing the chiller. With the building energy demands clearly understood through transparent flow and load information, the chillers are ready to be sized and staged correctly. This right sizing delivers an additional 10% plant energy savings. In practice, we see that the plant systems are often oversized. In an upgrade, the tendency is to replace with like-for-like capacity while building demands have changed over time and occupancy changes, and internal loads have reduced from light upgrades and other advances in technology. Add to these the tendency to apply safety factors further adds to oversizing. With a pump-first approach, the optimal path to a plant upgrade is assessing the transparent information to right-size the plant and achieve optimum efficiency, not only delivering up to 40% energy savings, but also reducing capital cost upgrade costs by as much as 20 to 30%. Now, how do Armstrong solutions enable this manner of design thinking? Well, as I shared earlier, digitalization has changed the scope of devices. Armstrong's new intelligent pumps not only function as smart pumps, but are also 3 to 5% accurate when measuring flow. These pumps come with embedded active performance management software, which I will touch on in a few slides, that is built on design on-board technology and is powered by IBM Watson Intelligence to learn, predict, and optimize in real time. With the intelligent pump, we now have a monitor on the heart in the mechanical plant, much like a smartwatch can monitor your heart rate and provide insights on your daily routine. This feeds into Armstrong's suite of automation and optimization solutions for your mechanical plant, which have been developed using the flow informs approach. While most existing mechanical plants operate at efficiencies of over 1.1 kilowatts consumed per ton of cooling delivered, Armstrong solutions can help bring it down all the way to 0.48 kilowatts per ton on average. Of course, these numbers have been confirmed using Armstrong's Active Performance Management Suite, which enables intelligent monitoring of mechanical equipment within your plant. Armstrong also has case studies from across the globe for all the solutions I've outlined so far on its website, armstrongfluidtechnology.com. So please help yourselves with that information as well. So why connected equipment? With the rapid expansion of the Internet of Things, globally speaking, buildings are becoming smarter in many different ways. From user-facing elements like lighting and elevators, to more behind-the-scenes systems like security and HVAC. Ultimately, the notion of connectivity paves the way for the next leap forward in our collective journey to make intelligent buildings that sustain their efficiency and performance over time, what we call persistence. This visualization illustrates how connectivity completes the operation cycle, whether we're talking about connected equipment, connected customers, connected users, or connected service dealers. Connectivity is the key driver in keeping intelligent buildings performing at their peak efficiencies over the long run. Commissioning, even continuous commissioning, is still at a specific moment in time. But only through connectivity can end users really start and stay optimizing their equipment and their facilities. And this principle of connectivity leads us perfectly into active performance management, because knowing is half the battle. One of the primary tenets of maintaining intelligent buildings is the ongoing activity of tracking and benchmarking performance. Simply collecting performance data is not enough. The collected data needs to be reviewed on an ongoing basis, and performance needs to be actively managed in order to realize the full potential of an intelligent building. Armstrong's Active Performance Management Program uses cloud computing technology to deliver real-time insights that enable building operators to make informed decisions and take prompt action without delay. The following value drivers inspire our digital service offering. Performance management, which is the capability to identify issues before they become big, by providing alerts and alarms at the user's fingertips. Asset management. This is essentially being able to have access to everything from pump info, configuration settings, firmware updates, to service reports, and so on. And finally, value chain integration, what we see as a huge opportunity to connect partners to customers for faster response through the click of a button. It is now easier to connect the customer to system experts, value-adding tools, and so on. Next, let's take a look at the core features of these cloud services. All performance management services contain these 6 core features. Secure IoT connectivity, which is a plug-and-play setup that does not require access to LAN. Real-time alerts, where the end user will be notified of issues before they become catastrophic. Performance reports, where summary findings are aggregated on an ongoing basis. Predictive maintenance, where Armstrong goes beyond automated fault detection and diagnostics and into predictive maintenance. BMS integration, where controls and data can be shared with local on-premise building management systems. And finally, Armstrong support, where Armstrong and its service network are available 24/7 to provide customer service and technical support. So what are the benefits of this suite to the end users? Well, the benefits of having a connected device with enabled digital services are overwhelming. From energy savings to maximum uptime to the general peace of mind knowing that the pumps are running optimally and that they are one click of a button away from getting support from the right service partner. Also, in our experience, many end users don't like to have multiple screens or dashboards. Therefore, we have a way to link our suite of solutions into other systems, such as your BMS, EMS, CMMS, and so on. Now, over the next set of slides, I will dive into Armstrong's digital services, namely Ecopulse and Pump Manager, in more details. So now we have a high-level understanding of active performance management as a concept. Let's dive into the details of the 2 services I mentioned before, the first of which is Ecopulse. Ecopulse is an energy management system for central plants. Typically, that means chill water plants, but it can also apply to boiler plants. It is the flagship performance management offering for any chiller plant. In short, Ecopulse keeps a finger on the pulse of an HVAC system. By doing so, it empowers plant operators to keep the systems running efficiently and optimally over the life of their chiller plant. The tagline is Your Future Daily, as in it gives you a picture of what your plant behavior might look like tomorrow based on its behavior today, yesterday, and all other days it's captured historically. As such, actions can be taken to avoid negative trending behavior in advance of tomorrow. That's the active part. So let's take a look at Ecopulse's key features next. They're delivered through 3 vistas, a cloud-based component, an email-based component, and a technical review component. So first, the high-level overview and detailed view. The web portal is accessible by the end users anywhere they have an internet connection, so you're not limited to your mechanical room. Next, the daily notifications, where emails are generated daily, which recap the performance of the system over the previous 24 hours. And when irregular behavior is recorded by key performance indicators, it is noted in the daily summary. Finally, the ongoing review and quarterly report. A team of Armstrong technical engineering staff review system performance data and generate recommendations for efficiency improvement where applicable. So what does Ecopulse look like? The landing page displays the financial summary comparison between our pre-sale predicted versus actual operating cost based on the cost of power for that specific jurisdiction. The table lists year-to-date, previous year-to-date, month-to-date, and previous month-to-date predictions versus actual operating costs. Additionally, along the bottom, a visual representation of the spending on electricity compared to prediction and compared to last year. The predicted performance page displays the base case, which you see in gray, predicted case, which you see in red, and actual case, which you see in blue, for real-time energy savings due to the energy upgrade. The 3 charts plotted along a 52-week axis, and as the next day enters from the right, the last data on the left gets punted, and a rolling 52-week period remains at all times. So on a normal day, you will get a message of the system indicating how it has performed. And if a deviation happens, such as in this case, it will be detected. So this was a short overview on Ecopulse. Next, let's take a look at Pump Manager. Of course, now we know what Ecopulse is. Talking about Pump Manager becomes a whole lot easier. Pump Manager is to Armstrong Gen 5 pumps. That's what our latest suite of pumps is called, and what Ecopulse is to central plants. It's powered by IBM Watson's Cloud Analytics engine, and Pump Manager enables active performance management for Gen 5 pumps. In a phrase, Pump Manager enables active performance management in intelligent design envelope pumps. And at the highest level, Pump Manager can be described as a cloud-based performance management service with industry-leading analytics that generate pump-specific insights like deadhead and broken couplings, which ultimately lead to enhanced reliability and sustained optimal equipment performance. And additionally, Pump Manager is also an asset management platform. With Pump Manager, we can now manage items like commissioning reports, change management, and firmware versioning. I'll circle back to this paradigm in a few slides. Today, powered by IBM Watson's Cloud Analytics engine, we're able to detect pump behaviors like deadhead, excessive vibration, and cavitation, which are also incidentally some of the most common issues you see with pumps in the field. Shortly, we will be adding advanced features such as the onset of mechanical seal and bearing failures. And additionally, monthly performance reports are generated in the cloud and shared with end users through an automated email service. So what does it look like? Our summary dashboard now totalizes dollar, energy, and CO2 savings for an account user at a glance. And active alarms, alerts, and warnings are highlighted below. Built-in real-time vibration analytics for predictive asset condition management is also available. And as you can see, it gives you vibration analytics in all three axes, telling you and giving you a better idea of what is actually going on with your pump. From a single location, you have access to I&O manuals, submittals, and firmware downloads for your specific pumps. So, no need to go looking around and contacting manufacturers for all this information. It's all available at your fingertips. And it maintains a comprehensive history of changes and service interventions to the pump and links directly to your CMMS systems. Again, ensures minimum running around and minimal issues and minimal back and forth when dealing with any sort of repairs or issues with your pump. And finally, it gives you access to the right support with the right parts at the right time. So, how does everything I've spoken about come together? Here's how. Combining the flow data with temperature data provides us with new insights into system performance. We use this data and insight to create a digital map of the equipment. This digital map is then used to create a digital twin of the equipment. With this digital twin, we can now assess all subsystem performance and identify performance degradations before they become major issues. And to accelerate these learnings, we can leverage large population cloud analytics. Building systems learn from each other by sharing operating data. Today, with this experience, we can configure mechanical plants to provide the same reliable capacity, but at much lower costs. In the top right corner, we illustrate this concept. A traditional plant would have 3 of each major components, including the distribution pumps, chillers, condenser pumps, and cooling towers, sized at 50% of max capacity. With the digital approach, the 30% first cost savings are achieved by a combination of equipment as 3 distribution pumps sized at 40% of max capacity, 2 chillers as opposed to 3 sized at 55% of max capacity, and 3 condenser water pumps sized at 35% of max capacity. And finally, the cooling towers, as in the original plan, sized at 50% of max capacity. Therefore, in starting by upgrading your pumps, you can introduce intelligence and demand-based control at the most basic level. You can then leverage this information and control to right-size your larger components like chillers and cooling towers. This will help you minimize not only your energy usage and its associated carbon emissions, it will also lower the overall carbon footprint of the equipment in your buildings due to smaller sizes, fewer pieces of equipment. And given the large carbon footprint of HVAC systems in built environments, This is a significant step in any building's journey towards a net zero carbon future and cannot be missed. Thank you, everyone. That is my presentation. If you have any further questions, you can go ahead and enter them in the comment box below, and I will respond to them right away.